everyone, welcome to my channel. I am Aryan, and in today's video we are going to discuss about the linked list. In this video you are going to learn the basic of linked list, and I will also show you the implementation of linked list from scratch in Java, right? Okay, and we are not going to use the packages, okay, so that's why I have written scratch. We are not going to use the Java collection framework for it. We will do it from the scratch so that your concept and your understanding of the linked list is clear at the end of the video. So let's get started by first visualizing how a linked list look, right? So this is a linked list. I've made a diagram consisting of three nodes. So what's a node? Well, this is the node. Okay, we have three nodes like this, right? Each node is further divided into two parts, you can see. Okay, the first part being the data and the second being the next pointer, right? Okay, so the data you see here, it's of integer type number 3, right? Well, it can also be of character, it can also be of float, it can also be of double. Okay, it's up to you, right? Now what does the next pointer do? The next pointer stores the address of the next node, right? So like you can see, the 2000 is storing the address of the next node, right? The 1000 is the address of the first node. You can see a head pointer over here that stores the address of the first node, okay? And this is the last node as it points to the null. Okay, that's how I know it's a last node, right? That's how the computer knows it's a last node, right? Okay, now why do we need the next pointer? Okay, I will come to it very soon. Okay, let us understand the purpose of the head pointer. So the head pointer is needed so that we know the location of the first node. Okay, and the next pointer helps us to access the other node connected in the linked list. That's why we called it a linked list, right? Now why really do we need a next pointer? So let's understand it now. So it's all about the memory storage. If you have studied the arrays, you will know that we don't need such pointers in arrays. Why? Because in arrays it is sequentially stored, right? I mean, index 0 may be at 1000 and index 1 may be at 1001, the next may be 1002, okay, right? Depending on how much storage it takes and all, they are sequentially stored so they can be accessed very easily. Yeah. While memory storage of linked list is random. That means whenever you create a node, it is allocated a random space. What do I mean by random is where suppose when I made a node 1, it is given the space 1000. That doesn't really mean that node 2 will be given the space 1001. It can be given anything, 2000, 3000, 500. Okay, so that's why we need a next pointer so that we know where the next node has been created. Okay, so the next pointer will store the address of the next node, and thus we can access it later. Okay, and so yeah, that's it. In this video I'm going to teach you three basic operations. One will be addition of the node, one deletion of the node, and then linked list traversal. We are going to see addition of node at first, then at last, deletion of node at first, and then at last. Okay, and yeah, we are also going to see addition and deletion of the nodes at specific index position. Okay, that will be covered in the last part once you are done with this basic, right? So what you need to know is there are not one type of linked lists, but actually many types. Well, I've written three of them here. One is single linked list, one is doubly linked list. What is in the doubly linked list is previous and next pointers. Okay, yeah, I need to tell you one thing. The single linked list, as you saw in the diagram, the arrow always pointed in one direction, right? That means you can go from the first node to the last node, but never from the last node to the first node. In the doubly linked list, you have two pointers. Okay, one is a previous pointer, one is a next pointer. So with the help of the previous pointer, you can also go to the previous node. So it means you can go from the first node to the last node and from the last node to the first node. There is also a circular linked list. Okay, so as you know, in the linked list, the last pointer points to null. In the circular linked list, the last node will point to the head. So in a way, creating a circle, right? Now let's get started with the implementation in Java. So this is the Visual Studio code that I'm using, right? I have made some basic implementation. I made a class linked list and I've made the main function. Okay. So before we get started with the function, we need to define a class node, right? So what do we have in that node is the data and its pointer. So let's define them with the data and the next pointer is type node, right? Okay, whenever we create a linked list, what we want is the data to be assigned and the next pointer will be null initially, right? Because at that time we don't know what what to point, right? So this is a constructor that I have made. Okay, I would assume that your concept of hooks is clear, okay, before you are watching this video. And well, if it's not, you can go and clear it. Or if you want me to make a video, I can definitely try my best to help you understand the whole concept. Okay, so yeah, now we're making the constructor. We will assign the data. Okay, this data means this one. We'll assign to data which is passed in the constructor, and then this dot next will be assigned to initially, right? Okay, so that is the basic declaration. We also need a head pointer. So let's define head, and then we also need size, well, in size to keep track of the linked list size, right? Okay, yeah, and size we can also implement it directly over here. Whenever a new node is created, the size definitely needs to be incremented. Okay, yeah, that's it. Now we'll get started with the function. Okay, so the first function we are going to discuss is the add first function. Okay, so I've just made this for understanding purpose. We need a new node over here, right? We need to add it in the first. That means we want this one to be the first node. So what's special about the first node? Well, the head pointer points the first node. We can point this head pointer to the first node, but you can't do it directly, right? If we point this head pointer to this node, then what happened to these nodes? They are just inaccessible, right? So what we'll do is we'll point new node to this node, okay, and then we'll point the head pointer to this node. So we'll do new node equals to head, right? And then health equals to new node. Simple as that. Okay. Back in the Visual Studio Code, we will write a public void input first. This will take a data, of course, right? And then we'll create a node, new node equals to new node, just like we create an object, right? And we need to pass a data because we have a constructor for that, or we need to include this data. Okay, so this data is basically passed here. Wait, now what we need to do is new node equals to head, right? And the head, we will shift ahead to the new node. So that's the first element. That's it. But we also need to take care if the list is empty. If will equal to null. Okay, you can see that we haven't assigned null here. Okay, so when we have not assigned anything, it's null. Okay, so when the list is empty, what we are adding is actually the first element, right? And it is also the last element. So what will happen is the next pointer must be null. So yeah, we already have it null over here. We don't need to do that, but we need to point ahead to it, right? So we don't actually need this one. Okay, so we write it here. And once this is done, we don't need to further execute the code below. Just return somewhere. So that was all for the practice function. Okay. Now let's go to the next one. The next one we are going to discuss is the last function. Okay. So in this function, well, we need to do a little bit more than what we did in the last one. Okay. So I have made the new node over here. This is the basic English we had in the last slide also, right? So what we will do over here is we will need to first of all, okay, before we just remove this pointer, null, point it over here, right? What we will need to do is actually traverse this node, right? As you know, we can just directly access this node, okay? So what we will need to do is to make a temp which will point to the head, and then we'll need to come to this node, right? And then we'll need to do the temp dot next equals to new node, and then the new node dot next equals to node. But that's not at all complicated. You might think it is, but while coding you will understand it very well. Also, I want to tell you one thing. As we make a head, people usually also make a tail to keep track of the last node. No, this is just made easy. Okay, so the tail part, I think you can do it on your own once you learn all this. So I would tell you just give it a try. Okay, so back to the coding again. We'll make public void last right? Then we'll pass in data, and then we need node, new node equals to new node of data. That's all, right? Now, what do we need over here? We also need a node temp, which is equal to head, which will point ahead, right? Why do we need a temp is for traversing the linked list. Now, understand this thing. The linked list traversal, which I told in the basic operation, is actually used for these cases, right? To traverse the linked list versus the last node and all. And also it can also be used for printing the linked list, right? Which I will cover. Okay. So now we made the node temp. Okay. We need to access the last node. So we make a while loop, while what? Temp.next is not equal to null. Okay. We'll go temp equal to temp.next. Okay, what will happen is, like suppose we have 1 2 3 in the linked list, the temp is here, the head one. Okay, the next one is not null, so it will jump, okay, to the 2. The temp will point to 2. Now we need to check if next is null. No, so then it will jump here. Now we will check in the third one if it is pointing to null. If it is pointing to null, it won't jump to next one. So basically we will be accessing the last node with this while loop, going to last node. Okay, once we are in the last node, well, what else do we need? We just need to do the, you know, once we are already at the last node, we just need to change the pointers and all, it will work, right? What we need to do is temp.next equal to new node. And well, that's all. And well, yeah, that's all. That's the code is over. But well, here also we need to take care if the list is empty. Okay, if head equal to null. Okay, even though we are doing at last, it basically is same as at first, right? So what we will do is add to new. Now this thing we are writing over here, this if condition that we have written over here is basically called corner cases, right? The corner cases are some cases we need to take care of during the code writing. Okay. Okay, so we have written two functions for addition of nodes, right? At the first position and at the last position. Now let's get started with deletion, right? So deletion at the first we'll do first of all, right? So what does deletion at the first actually mean? Okay, we need to remove this node, right? This one. Okay. So this is the most simplest thing. Okay. You just need to remove the head pointer and point it to the next. So what we need to do is just say head equals to head dot next. Okay, this line is very simple. Okay, you just need to understand. It's not difficult at all. What we are doing is head, that is this one, equals to head dot next. So head dot next. That next is basically this node. Okay, so we are just assigning the head to the next node. Okay, so what happens to this node? Well, Java we have a garbage collector, so this node is not accessible, right? So it will automatically delete this node, okay, in this page. So basically, we don't need to delete this node, okay. If it were the C programming language, you need to reallocate the memory, of course. But here Java makes it easy for us, so we just don't need to. Okay, so the reason I have written int is because we are also going to return the data which present at the node which we are going to delete. Okay, yeah. So let's just get started with this. If okay, but we'll cover the corner cases afterward. What is the first thing you need to do when removing a data? Well, we need to reduce the size of the linked list, right? In the add one we didn't increase because it's already increased here for creation of nodes, right? But over here we'll need to remove it. Okay, and yeah, also note this. This is a node, but we are not accessing this constructor, so it has no effect on the size. Okay, you might also be thinking that I made a node here and the size must have increased while this is not actually a node. But we didn't call the constructor, so the size haven't changed, right? We just assign it to the head, and so the size have no effect. Okay, I know you guys are smart, you know that, but just in case. Okay, now what do we need? Is we need an int val. What will be the value? Well, at dot data. Why at dot data? Well, we want to get the first node. The first node is always pointed by the head. So at dot data is the first node dot data, right? And we'll return value. We need to return. Okay, that's it. Now we need the node. So this first head dot next. Here the node is removed. Okay, node remove. Right. Now this also has some corner cases. Right. First of all, if size equal to 0, that means the linked list is empty, right? We just need to print out that list empty. Okay, and we will return well what we should return, because in previous one we had void, so we just write return it's done. Here we cannot write only return, so we will return uh, integer dot mean value, right? Integer dot mean value is simply the smallest value possible so that we don't get confused. Okay, so this we have written the case for when the linked list is empty. What if the linked list have one node, right? That is, it is the first node and also the last node, right? We can also write int val equals to the data, right? Again, and then we write size minus minus. And then what we need to do over here is head equals to null, simply like this. Okay. Because the linked list will be empty, so head equals to null. It can just return from here only. We don't need to run the code again. We don't need to go for the below code, right? So that was the remove first function. The next one is the delete last function. Okay, so we are going to delete this node, right? We'll need to traverse to this node, okay, using a temp variable, and then we can just do temp.next equals to null. So this node will be unaccessible. Once it is unaccessible, Mr. Garbage Collector comes and tells, okay, you have no use and you need to go. So it takes it away, and boom, memory deallocated, right? Okay, so let's just code this. So inside the remove last function, we will make a node temp which will be initialized to head, right? Then we will traverse till this to one before the last node, right? So until temp.next is not equal to null, we will traverse the linked list. So temp will be temp.next, right? We'll move nodes. What we need to do is just make a int val which will have the data of the deleted node. Okay, of the node we are going to delete. So temp.next is the node we are going to delete. What we need is the data of that node. So dot data. So we have the data of the last node now. Okay, so now we can just delete the node, no worries. So what we do is temp.next is equal to null, right? And yeah, the garbage collector will do the rest of the work first. Now return val, the value is returned. Okay, so this is the code. Now let us see the corner cases. The corner cases will basically be this one, same one. So we can just copy and paste them here. These are the corner cases, right? And with this, we are done with the remove last also. And before we move to the next one, let me just make the main function and show you the working, right? So we will make a link list L1 equal to new link list, right? We made this. Now L1 dot add first, let's add 2, then L1 dot add first, let's add 1. Okay, so the link is 1 2. Okay, now L1 dot add last, putting 4, then we'll put 3 and 4. So this is the data we have added. The linked list is like this 1 2 3 4, right? Okay, so now let us write the printing function. So public void print nl. Well, nl is just a short form for the linked list, right? So to print it, we need to traverse it. So we'll need, of course, a temp, right? You will need temp a lot. So temp is your friend over here. Until temp is not equal to null, well, to move it, even though the temp is null, it doesn't matter for us over here, okay, because we don't need to perform any operation, we just need to print. So what we need to do is this Without temp dot data. Okay, and let's add some decoration. Okay, well, of course we don't need this thing. Let's add some decoration. Okay, yeah. So we will just in the linked list like this, and then of course we need to increment the temp. Increment means just move the temp to the other nodes and keep printing. And once this is done, of course we need a null over here. Let's just remove the data in the next line, just in a single line. So that's why just run it. And okay, why don't we have 1, 2, 3, 4? I think we have a problem in the first function. Let me see. Okay, over here, right? Okay, my bad. Actually, everyone, please correct this. New node dot next. You actually need to do this. There is a problem in this. Okay, maybe when you will see the video, I will correct it while editing. So no worry. So here, yeah, we need the new node dot next. Okay, that needs to be here, not the new node because we're just pointing. Okay, I'm sorry for this mistake. And now we're done. See, 1, 2, 3, 4. This is perfect. Now let's go with the further operation. So the next thing we need to do is add index. Okay. What do I mean by add index is add an index 2. Let's assume we don't want to add at the first, neither at the last, but in between. So what we do, we need to add at index 2. So this is index 0, 1 and 2 will be here. This is 2 actually right now. But when we add this, this will be the index 2 and this will be index 3. So for that, we need a temp, yeah, and we'll traverse the temp to this one. Now what we will do over here is we will make the new node dot next equals to temp dot next, this one, right? Then what we will do is temp dot next equals to new node. We'll point it here. So in this manner we will do the add index function. So let's make it new node. First of all, let's create the node, right? Equal to new, sorry, data, right? Then we will make node temp for traversing the linked list, and then let's make a I equal to 0 variable. Okay, now this is the variable we will need. Yeah, I forgot one thing over here. We will need index also, right? Main index perform. Now what we'll need to do is while, okay, while I is less than IDX, which is the index we want to insert, minus 1. Why minus 1? Because we don't need to reach the IDX node. We just need to reach one node before it. Right. So that's why what we will do over here is temp equals to temp dot next plus. Okay. So what this while loop will do is it will help us to access the node of index. Okay. Like if we want to insert at index 2, we need to access the node before it. That is index 1 over here. So with this line of codes, we will be able to access that particular part. And what we need to do next is the node dot next, right? That will be pointing temp dot next. Okay. Now we need to change the temp dot next pointer to new node, right? And we're done with the add index code. And now let's cover the corner cases. Okay, the first corner cases is what if the index is greater than size? That's not possible, right? In a size of 5, the maximum index can only be 4. So it can't be greater, it can neither be equal to size. So if this is it, then well, the linked list is out of range or the index is out of range. Index higher size. That is enough. Okay, this is the first corner case. And what if if the IDX is equal to 0, right? But basically, we just need to add first. So instead of writing the code, just write add first data, and we can just hit them. So this is the function of add index. Okay, this is so simple. And now let's get to the delete index, right? Now let's say we want to delete this, which is at index 1, right? Delete at index 1. What we need to do? We need to access the node before that. Okay, temp equals to help. Here we will not need to traverse in this diagram. Okay, what we need what we need to do over here is pretty simple actually. Temp.next is equal to temp.next.next. Well, it might sound a little confusing, but it's not confusing at all. What I'm trying to say is temp.next, this one must point to temp.next.next, means it must point to here. So once this points to here, this node becomes unaccessible. And yes, Mr. Garbage Collector will come and take it away. Okay, yeah, so now let's get to the coding part of our remove index function. So public int remove text. Okay, we need to also return the data from there. Okay, so we'll need a uh, we'll need a node temp. Of course, initialize this to head. Right? And let's make a for loop here. And I is less than idx dollar minus one. Okay, and we'll just go temp equals to temp dot next. Okay, with this we will arrive one node before the node we need to delete. Right? Before the deletion, we need to access the value. Right? So temp.next, which is the node to be deleted, the value is the data. We got the data from there. That we got the data. Now we don't need the node, so we can just delete the node. So temp.next, okay, the node before the node that is going to be deleted must point to the node that is after the node to be deleted. Okay, so try to visualize this. Okay, once you visualize it, it will be very clear. Dot next. Okay, then we'll just return the value. This is the code for remove index. Of course, it has some corner cases, so the same over. You can just copy paste it. It is the same code over here, and done. Also, there will be one more thing. Here we'll need to do integer dot value, and over here it's not integer domain value. We need to return this one. Return of first, return remove first, and then there will be also one more when idx is equal to size minus 1. So we'll do return remove last. Okay, we are done with our function. Now let's see if it really works. So we have this linked list 1, 2, 3, 4. Okay, now let me just make this. I will make it 6 here. So now the linked list over here will be 1, 2, 3, 4, and 6. Add at index 4. Dot add index. Okay, no, we need to add at index 4, and we need to add 5. Okay, after this, after printing, we let us see if the remove index function is actually working. Remove with the 4 again, print it again. And actually, guys, I did made a mistake over here. I forgot to write the int in idx while showing the code of remove index. So, guys, please correct it if you have the same problem. Okay, so we are done with the code of linked list, implementation of linked list. Let us see if it actually runs. And yeah, okay, I've run the terminal twice. So yeah, this is the print error over here, which should be 1, 2, 3, 4. It's perfect. And we added a last 6, and then we added a 4, so it should be 1, 2, 3, 4, 5, 6. Good. And then we removed the fifth element, and the fifth data we added. So it is again 1, 2, 3, 4, and 6. So yeah, the code is working perfectly. Okay, guys, I hope you like the video and you understand the linked list concept. So this was the code for the linked list. We did the implementation in Java from scratch, right? If you will do the same thing with the use of Java collection framework, it won't be even 30 lines or not even 50 lines, right? It will be very less line of code. But well, this was for your concept clarity. Now you understand this thing. It will be much easier for you to do the questions. And this was only the single linked list that I have covered. There is a double linked list, there is a circular linked list. There are also some questions related to linked list which are really important, which I will bring in the further videos. Okay. So guys, if you like the videos, please drop a like, and any doubts, write in the comment.